Hello viewers, welcome to UNC Digital class. Myself Rasmita Jena, lecturer in computer science. So today I am going to discuss the remaining part of the array in data structure. In our last videos, we are already discussed about traversing array, inserting a new element into an array and deleting an element from an existing array. So in this class, I am discuss that how we can search a particular element in an existing array. So first we have to know what is searching. Searching means we have to search a particular element in an existing linear array and we have to return the location where we found that element, or we have to display a message if that item is not present in the existing array. Okay. So let us see how we can search a particular element in an existing array. So first we have to know what is searching. Okay. It refers to search a particular element, or this operation is refers to search a particular element. It refers to the operation to find, or you can say to search, to find a particular element or item, in an existing array. Okay. This is about searching. And when we search a particular element in an existing array, and in that case we have to print a message that we get that particular element or not. If we get that element, then it will return the location where we get that. Or if we do not get that element, that means if the element is not present in the array, then in that case we will also print a message that the number is not found or the number is not present in the array. Next we will see that if the number is not found, then we have to print a message. So, or printing a message okay. Printing a message that the item is appear or not, that the item is present or not. Okay. This is about searching. Searching means it refers to the operation, or we can say searching refers to the operation to find a particular element in an existing array, or we can say printing a message that the item is present or not. If we found that item, then we will return the location, or we will return the index number of the array where we get the element, or if you not found the element, then we will print a message the number is not present in the array. So let us see what are the requirement for writing an algorithm or writing a function or writing a program. So when we search an element, the requirements are, we need a linear array. Suppose that array is A, okay, and then next size of the array, that is n. This is your linear array. These are the requirement. Then next, or you can say what are the input for searching a particular element, the linear array. Then we have to declare the size of the array, okay. Then next, the number is to be such, okay, the number is to be such, okay. Suppose that represented as the variable item, okay. So these are the input we need to search a particular element. Next we will see the algorithm for searching an particular element. For search an element into an array, suppose name of the algorithm is search, and the input required for searching is the linear array. Suppose that represented as A, then next size of the array, then the item to be sourced, that is stored in the variable suppose item. Okay. Let us see the memory representation of the linear array and how can we search a particular element in an array. Suppose this is the array of 50 size, okay, and suppose we are inputting the size as 5, okay, and the item is to be searched, that is suppose 50, okay. So, this is the array, okay, and as we are inputting the size of the array is 5 and we know that array index starts from 0 location. So, this is the A of 0 location and next one is your A of 1, A of 2, A of 3 and A of 4, okay. As it is declared as 5, so the range of the array is 5, so we can store maximum 5 element into an array. Suppose the array contain 10, 20, 30, 40 and 50, okay, and the item is to be sourced, that is 50. That means we have to source the item 50 is present in array A or not, okay. So, what we will be do in first iteration? So, the steps are, in first iteration we will match the item with A of 0 location data, okay. If it will match, then from this location we will exit, okay, and if it will not match, then we will increment the counter variable value, and in the second iteration we will check for the second array location element, that is A of 1 is equals to item. If it will match, then we will return. If not match, then we will again increment the counter variable. So, like this we will proceed, we will check all the elements, that is the item is compared with all the array index location, that is again A of 2 will match with this will not match, then again increment your iteration, increment your counter variable value, then again match with A of 3 with this item variable. If it will not match, then again increment the counter variable value, then it will not match, again we will compare with, again we will increment the counter variable value and compare with A of 4 with item, it will match. Then when we get our matching item with the linear array, then at that point we will return the index number or location where we get the item. That means in this case we will return 4, that is the current value of the counter variable, okay. Let us see the algorithm. So, in step 1, according to rule of the algorithm, we must write start keyword for the start of the algorithm, then step 2, okay. In step 2, we will initialize the counter variable, set, suppose our counter variable I equals to 0, okay. Then comes to step 3. Then in step 3, we will take a loop, because every time we will check each and every location of the array with the item, okay. So, for that we will take a loop. So, for that I can write repeat step 4 to 6, okay, until the condition is true. What will be the condition? That means we will check from this location to this location, okay. So, as we set the counter variable I equals to 0, so the condition became I less than equals to n minus 1, or you can write I less than n, okay. Then comes to step 4, okay. In step 4, we will check each location of array element with the item variable by using a if statement. So, we can write if A of I equals to, or in algorithm only you have to write equals to, because in program we will write equals to, but in algorithm we can write simple equals to, that is if A of I equals to item. If it will be true, okay, if it will be true, then we will execute the body part of the if statement or block of the if statement. That is, in step 5, it will return the location where we get the item. If this condition is true, okay, this condition is true means we will get our searching element at this location. So, in that case, we will return the index value of the array, that is I. Okay. If this condition is false, that means if A of I is not equals to item, then end if. That is step 6. That is end if. Sorry, we can simple write end if. Okay. That means if this condition is false, then from this location to this location we will go, that is end if. In step 4, what we will do? We will increment the counter variable for checking the next array location. That is, we can set I equals to I plus 1. That means initially if I equals to 0, then we will check A of 0 equals to item. Our item value is 50. A of 0 means it contains 10. So, 10 equals to 50. This condition is false. And whenever this condition is false, we will go from this location to this location. That is from if to end if. Okay. Then after that, so when this condition is false, that means A of I equals to item. You just see that is A of 0, that means 10 is not equals to 50. So, this condition is false. As this condition is false, so we can go from this location to this location. Okay. After that, we will increment the counter variable bearing the next array index with the item. So, for that I can write I equals to I plus 1. That means initially I equals to 0, and when I incremented I by 1, then it will become 1. Then from this we will again go for step 3. Okay. Because until this condition is true, we will execute from step 4 to 6. Okay. So, we will check I less than equals to n minus 1. That means I became 1, 1 less than equals to n minus 1. As n equals to 5, so this condition is again true. So, as this condition is true, then we will go for step 4 and we will check this condition, that is A of I equals to item. It means A of 1 equals to item. A of 1 equals to 20 and item is 50. So, this condition is again false. Okay. As this condition is again false, so we will go from this location to end if. Okay. After that, again I will increment the counter variable value I. So, after incrementing I by 1, I became 2, and again we will go for step 3. Okay. In step 3, again we will check the condition, that is I less than equals to n minus 1. That means 2 less than equals to n minus 1. N minus 1 is 4 and 2 is less than n minus 1. The condition is true. Okay. This condition is true because 2 less than equals to 4. As this condition is true, then we will execute this statement. That is, if A of I equals to item, that means A of 2 equals to item. We will check the condition, A of 2 is 30 and item is 50. So, this condition is again false, and we will go from this location to this location. And in the same way, we will increment I by 1. Suppose 3, and when I incremented 3, we will again compare A of 3 equals to item. The condition is again false, and we will again increment I equals to 4. Okay, by incrementing the counter variable value by 1. And when I equals to 4, we will again compare 4 less than equals to 4. Condition is true, and when the condition true, we will compare this statement, that is A of I. That means A of 4 equals to item. You can see A of 4 is 50 and item is 50. So, this condition is true. As this condition is true, then we will execute the statement which is present within the if block, and we will return the I index value, that is I equals to 4, and from this location we will return the location where we get the item. Okay. And until you don't get the item if the item is not present. Suppose 50 is not present and this condition is false, and you will exit from this to step 6. Okay, and after that the step 7, that is stop the procedure or exit. Okay, so this is all about your algorithm to search a particular item in a linear array. So next we will see the function implementation of this algorithm. So next we will see the function implementation. Suppose you can see here the index number is returned to the function block. Okay, so as we know, in function we have 3 parts, that is function prototype, function definition and function call. Okay, that means from function call part to calling part, we have to return the array location where we get the searching element. So the prototype of the array becomes there must be a return value, and we have to mention what type of value we have to return. That means in function implementation we will mention the return type. So array index is always a positive integer number, so the return type is int, and the name of the function is suppose search. Okay, and the argument do we pass from calling part to call part, that is our array, that size and item which is to be search. So in the definition part we will receive an array, suppose array size is of 50, and the range of the array, that is int, that is stored in the variable n, and the item which is to be search, that is also integer type, and we will store that item in the variable item. Okay, so this is the prototype. If you put a semicolon, then this is the prototype, but here we are defining the function, only function of the algorithm. Okay, so just write the definition part of the user defined function. So this is the return type, that means we have to return the location, that's why I mention here integer. This is the name of the function, that is user defined, you can mention any name, and this is the array which is received, that means which passed from the calling part and received at the definition part. This is the size of the array, and this is the item which is to be searched. Okay, comes to this point. So first we have to set the counter variable, that means we must declare a counter variable, that is int I. Okay, and before starting the loop we will set a counter variable, suppose that is I equals to 0. In this case I will take a while loop for searching an element. So take while, according to syntax of the while loop, this is the initialization part, this is the looping statement while the condition is I less than equals to n minus 1. So I can write I less than equals to n minus 1. Okay, then inside the loop the statements are, the first statement is we have to check the element is matched with the array element or not, that means the searching element is matched with the array element by using a if statement. So for that I can write simple if a of I equals to item. This is the program implementation, that's why here I am writing equals to. If this condition is true, then within the if block I will write return statement for returning the location where I get the element, where I get the searching element. Simply write return I. Okay, this is the end of the if block. If this condition is not true, then simply increment the counter variable value, because for continue the loop execution we must increment or decrement the counter variable. So in this case we need to increment the counter variable. For that we can write I equals to I plus 1, then end of the loop. Okay, then implementation of searching, and this is the algorithm and this is the function implementation, and in the same way you can implement this function into program for the practical use. Okay, hope student you get knowledge how can we search a element in a existing array, and this is all about your searching algorithm. Thank you, have a nice day.